Good day, learners. I am Mrs. Katrina Javier Naldosa from Pasay City North High School, M. De La Cruz campus, and I will be your teacher for General Mathematics this first quarter, week 6, day 2. And for our today's lesson, our objective is to find the domain and range of an exponential function. Let us start by imagining the model of an exponential function f of x is equal to b to the x. What if the base becomes negative? So let's have f of x is equal to quantity of negative 2 raised to x. And let's try to graph it using decimals. So we have the points, we substitute the values, we have negative 3, negative 1/8, negative 2, positive 1/4. We've got negative 1, we've got negative 1/2, 0, 1, 1, negative 2, 2, we've got positive 4, and then for 3 as the exponent, we have negative 8. Look at how the points are plotted, the green points. Does it look like an exponential function? No, it's not a graph of the exponential function. So what if we evaluated this function and we evaluate 1/2? We are going to get f of 1/2 is equal to negative 2 raised to 1/2. We know that for the law of rational exponents, this is the same as the square root of negative 2. And for the square root of negative 2, we're just going to get unreal numbers, or what we call as imaginary numbers. So that is the reason why it's impossible to get a negative number for function of x in an exponential function. Now let's imagine the model of exponential function f of x is equal to b to the x. What if I have f of x is equal to 1 to the x? We're just going to get f of x is equal to 1, which will result to horizontal line. And for f of x is equal to 0 to x, same thing. We have a real number, but it will just result to horizontal line. Thus, we could now say that the domain of an exponential function is a set of all real numbers, and the range is a set of all positive numbers. We could substitute any value to x, but for the dependent variable, which is the y, or the range, it will just be positive real numbers. We could also write it in a set notation. D is a set of all x's such that x is any element of real numbers. While for the range, it's a set of all y such that y is greater than 0. Let's compare the graphs of 2 to the x, 3 to the x, and 4 to the x. You can see it here. They only differ from with their wideness. But still, let's find out the characteristics of this graph. So what if I'm looking for the domain of the exponential function? If you're looking for the graph and you're looking for the domain of an exponential function, you just need to take a look at the extent of the line going to the left and going to the right. In this case, we have positive infinity and negative infinity. Therefore, conclusion, domain is all real numbers. What about the range of an exponential function? The extent of going up and going down. And as you have observed, it stopped going down at 0. Therefore, the range is positive real numbers. And as I have said, the graph is always increasing if we have a positive base. Therefore, you could also write that the domain, this set notation. Now, what if we have y is equal to 2 to the negative x? So we know that since it is, the x is negative, we have reflected the y-axis. So in this case, we have this graph. Observe the domain of the graph. This can also be written as 1/2 raised to x. Therefore, we could conclude that when the base of an exponential function is still positive, but it's between 0 and 1, or what we call as a proper fraction, the graph will be decreasing. But still, the domain and the range would be the same as the parent function. Next one. Let's observe the graphs of y is equal to 2 to the x, y is equal to 2 to the x minus 1, and y is equal to 2 raised to x minus 2. So let's start by having this graph, the parent graph, which we all know that the domain and range, the domain is a real number, any real number, and the range is all positive real numbers. Let's graph a different form. Y is equal to 2 raised to x minus 1. What have you observed when it comes to the domain? Yes, it's any real number. And for the y or the range, it has also a horizontal asymptote as it approaches 0. Therefore, it's the same as the parent function. Y is a set of all y such that y is greater than 0. Let's graph another one. We have y is equal to 2 raised to x minus 2. And what have you observed? Same thing. Same domain and same range as the parent function. So what we have observed here is just it had only horizontal asymptote here, and there's only a horizontal shift to the right. Therefore, if you encounter any exponential function in the form of f of x is equal to b raised to x minus c, where b is between 0 and 1 and b is greater than 1, we could say that the domain is a set of all x's such that x is any real number, while the range is a set of all y such that y is greater than 0. We could also write the domain and the range in an interval notation. So for the domain, you could write it as negative infinity to positive infinity, while for the range, we write 0, to positive infinity. Take note, we use parentheses before 0 because that means 0 is not included in the solution set of range. Let's have one more kind of form of a function. Observe the graphs of y is equal to 2 to the x, y is equal to 2 to the x minus 1, and y is equal to 2 to the x minus 2. Let's start by the parent function. And I'll be posting here the domain and range. So we have the domain and the range. How about the next one? We have y is equal to 2 to the x minus 1. What have you observed? It shifted downward, and the horizontal asymptote also changed. But how about the values of x's? The extent of going to the left and going to the right. Yes, it's still negative infinity to positive infinity. While for the range, it changed the horizontal asymptote, so we're going to change also our range from negative 1 to positive infinity. Let's have one more. We have y is equal to 2 to the x minus 2. Shifted downward again. And still, the domain is the same, but the range has changed. As it approaches negative 2, it stopped going down. So we could say that the range is from negative 2, positive infinity. Let's have more examples. But before that, before we have more examples, let us have a conclusion here. If we have a function in the form of f of x is equal to b to the x minus c, our domain is still all real numbers. So from negative infinity to positive infinity. While for the range, we've got negative c to positive infinity. So it depends on the constant term. Let's have more examples here. Let's find the domain in the range of the following function without even graphing it. We're just going to check the form of the function. Y is equal to 51 to x to the x. So we have a parent function. So the domain is from negative infinity to positive infinity, while the range is from 0 to positive infinity. Next, we have y is equal to 2 to the x plus 1. In that case, still, whenever we have to conclude that a domain of an exponential function is a set of all real numbers. And then for the range, it depends on our c in this kind of form. So we have positive 1. So we have positive 1, comma, positive infinity. Next, let's have y is equal to 4 to the x plus 1. So in that case, it is in the form a while ago. Do you still remember the one with the horizontal shift? Therefore, it's the same as the answer in number 1 or the parent function. The domain, we have negative infinity, comma, positive infinity. And for the range, 0, comma, positive infinity. Last one. We have the form of, we have y is equal to 12 to the x minus 3. Take a look at the c, the constant term. So we have the domain is still all real numbers, while the range is from negative 3, comma, positive infinity. So let's sum it up. There are only three forms, three characteristics of the graph of exponential function. Let's start with the parent function. F of x is equal to b to the x. The domain is a set of all real numbers, while the range is a set of positive real numbers. The next form would be f of x is equal to b to the x minus c. You can see that the constant term is at the exponent. It's the same as the parent function. The domain is all real numbers, and the range is a set of positive real numbers. And lastly, we have the characteristics of the graph of an exponential function in the form of f of x is equal to b to the x minus c, where the constant term is just beside the base. So we have the domain is a set of real numbers, while the range is a set greater than the value of negative c, or in other words, the horizontal asymptote. And that ends our lesson for today. Did you understand it very well? If not, you may still go back to the lesson presented in your module. If today's lesson is very clear to you, congratulations! You may now start answering the exercises in your module. Good luck and God bless!